Hello. In this video, I'll discuss the many challenges that Bitcoin and other cryptocurrencies face and what is being done to address them. I'll take a quick look at the cryptocurrency Ethereum, which supports smart contracts for the development of decentralized applications. Finally, I'll mention many of the exciting applications and developments in the cryptocurrency space. Mining has a huge cost, estimated to be $25 per transaction. This cost is for the electricity to run the computers that are repeatedly hashing a block to generate the required proof of work. It has been estimated that Bitcoin mining uses as much power as the country of Denmark. One solution to eliminating the waste of resources in proof of work is to use proof of stake instead. We'll briefly discuss proof of stake later in this video. Bitcoin does not scale well. The maximum size of a block, which is 1 megabyte, limits the number of Bitcoin transactions to about 7 per second. In Ethereum, the number of transactions is between 20 and 30 per second. As a result of this, transaction fees have increased to between $2 and $100 per transaction. In contrast, Visa processes about 2,000 transactions per second, on average. In fact, Visa claims that they can handle up to 24,000 transactions per second. Bitcoin would need to be scaled to handle hundreds of thousands of transactions per second in order to be usable for ordinary transactions. A major challenge then in Bitcoin is to increase scalability while keeping transaction fees low. This is especially important since some countries are adopting Bitcoin as legal tender. One example is El Salvador, which made Bitcoin legal tender in June 2021. Two kinds of solutions are being adopted to meet the scalability challenge. One is rollup. In rollup, users sign up with a so-called rollup operator and transact with each other via the operator off the chain. Many transactions are batched into one transaction, which is written on the blockchain by the rollup operator. A second solution is to use something like the Lightning Network. Here, most transactions are peer-to-peer and off the blockchain. Participants commit an amount of currency on the blockchain. Two participants can open a channel with each other and use it for transactions that are not recorded on the blockchain. The transactions between the two parties are handled by a smart contract. When a party decides to stop transacting, they close their account, and all their transactions are consolidated into one transaction and written on the blockchain. Transactions are much faster, and the transaction fees are potentially much smaller. Also, micropayments, which are payments of very low value, are possible. Another major challenge that Bitcoin faces is the threat of centralization. In the beginning of Bitcoin, miners used the CPUs on their personal computers for mining. Over time, they started forming mining pools and using graphical processing units, GPUs, then FPGAs. Now ASICs, customized design hardware, are used in large server farms. There are now a relatively small number of Bitcoin mining pools around the world, fewer than 24 large ones. These mining pools can collude to make major future decisions about Bitcoin. Example, which fork to take, or whether to adopt changes to Bitcoin or not. This calls into question the extent to which Bitcoin can be considered to be decentralized. So the original one CPU, one vote vision of Satoshi has not been realized. Today, Bitcoin is rarely used as a currency for legitimate transactions in the ways originally envisioned. It is used as a mechanism for storing value, for example in countries such as Venezuela, that are experiencing hyperinflation. The inflation rate in Venezuela was 2.69 million% in January 2019. Bitcoin is used as a highly speculative investment, and it is used in illegal transactions, such as moving funds out of a country, buying drugs on the internet, ransomware, and so on. Certainly, these limited uses of Bitcoin cannot justify its 800 billion market cap. Despite the very high valuation of Bitcoin in the marketplace, the future of Bitcoin remains uncertain. As I've noted, Bitcoin faces several challenges. These include technological challenges, such as the high energy cost of mining and the very small number of transactions allowed per minute. There are economic challenges, including the fluctuation rate, and there's also the threat of government regulations. For example, the government of India is considering banning Bitcoin. China has also imposed severe regulations on Bitcoin. Nevertheless, a lot of work is being done to face these challenges. Bitcoin has certainly been remarkably successful as a proof of concept, and there is now a very high rate of innovation in the cryptocurrency blockchain space. Let me say a few words about the cryptocurrency Ethereum. Ethereum was invented by Vitalik Buterin in 2013. Vitalik was a University of Waterloo computer science student from 2012 to 2013 before dropping out to work on Ethereum. He is perhaps the most influential person in the cryptocurrency world. His Twitter page has 2.4 million followers. At a high level, Ethereum can be described as a blockchain-based decentralized computing platform. Vitalik's dream is that anything that can be decentralized should be implementable on the Ethereum blockchain. Ethereum's underlying cryptocurrency is called Ether. But Ethereum is much more than a cryptocurrency. It supports a Turing-complete programming language which can be used to describe so-called smart contracts. These contracts can be placed on the Ethereum blockchain and permit the development of decentralized applications known as dApps. It might be helpful to look at the Ethereum architecture. There are 4 layers in this architecture. The lowest layer, the consensus layer, is the Ethereum blockchain. This layer collects, verifies, and stores the data. The next layer is the compute layer. This layer implements a virtual machine that can execute computer programs that interact with the data in the blockchain. You can think of the compute layer as the Ethereum operating system. Above the compute layer is the application layer. This layer supports programs that implement decentralized applications or dApps, also known as smart contracts. A dApp captures some form of business logic. A dApp is comprised of code, a state, and a value. The code is public and can only be changed by the owner. All changes are transparent. Transactions of the contract subsequently change the state and the value. Above the application layer is the user interface layer. This is generally an application in the cloud which individual users can interact with. There is now a tremendous amount of research being done on all 4 layers of the Ethereum architecture. Ethereum got a big boost in February 2017 with the formation of the Enterprise Ethereum Alliance. Members included Microsoft, Intel, Cisco, JP Morgan, Credit Suisse, PricewaterhouseCoopers, Ernst & Young, and so on. The mission statement of the Enterprise Ethereum Alliance says the following: "Together we will learn from and build upon the only smart contract supporting blockchain currently running in real-world production, Ethereum, to define enterprise-grade software capable of handling the most complex, highly demanding applications at the speed of business." As of September of this year, Ethereum's market cap was $413 billion US. Many applications of decentralized apps are being envisioned and explored. The most promising area for dApps is decentralized finance. This area is well suited for dApps since no one trusts anyone in finance. The code in the dApp is open source, and all transactions are publicly verifiable. This has the advantage of providing maximum transparency in financial applications. Any financial product that can be modeled as a computer program can potentially be implemented as a smart contract. These include currencies, securities, derivatives, insurance products, and prediction markets. Here are some of the companies and organizations developing products for Ethereum's decentralized finance ecosystem. This list is almost 2 years old, and undoubtedly many more companies exist today. Some other promising application areas for Ethereum include record asset ownership for things such as digital assets, art, sports cards, game assets, and so on. Open marketplaces, for example, home sharing, car sharing, energy sharing, and so on. Contract signing without the services of lawyers. Decentralized social media platforms, unlike the present ones such as Twitter and Facebook, which serve as centralized data gathering services. People could have better control of their identities and their data. Lastly, I'll mention decentralized autonomous organizations, or DAOs, including for things such as crowdfunding and donations. In a DAO, individuals can contribute cash to an organization. A smart contract will govern how the investment will be managed in the future. Typically, investors will be able to vote on all decisions made with a vote that is proportional in size to their investment. If you're interested in learning more about cryptocurrencies, here are some topics that might interest you. I mentioned proof of stake. This is a consensus mechanism that eliminates the energy waste in proof-of-work blockchains. In proof of stake, miners put up a collateral which is known as stake, and are chosen based on the size of their stake to validate the next block. Misbehaving miners are penalized, for example, by slashing their stake. Ethereum has planned to transition from proof of work to proof of stake, which is called Casper. Blockchains that already implement proof of stake include Algorand, Cardano, and Definity. I'll mention Ripple, which is a permissioned blockchain aimed at banks and financial organizations that need to transfer money. In contrast, Bitcoin and Ethereum are permissionless blockchains. Anyone can participate in the blockchain. Zcash is an anonymous cryptocurrency that uses things called zero-knowledge proofs to enable anonymous transactions on the blockchain. Diem is Facebook's proposed permissioned blockchain-based payment system. Filecoin is a cryptocurrency incentivized, decentralized, and verifiable file storage network. In Filecoin, miners who store files do a lot of work to prove that they are correctly storing data. These proofs are useful, unlike in the case of Bitcoin's proof of work, so energy is not wasted. So Filecoin does power storage consensus and uses that to organize a huge amount of storage. Lastly, I'll mention work being done on interoperability for the thousands of cryptocurrencies and blockchains. Bridging networks enable dApps on one chain to call dApps on another chain. An example of a bridging network is Axlar. Here are a few references for further reading. You can explore Bitcoin by reading Bitcoin Magazine, downloading a wallet for yourself, checking out the Bitcoin blockchain at this website, and examining blocks at explorer.btc.com. For example, here's the Genesis block, the first block, and the 100,000th block of the Bitcoin blockchain. Bitcoin and Cryptocurrency Technologies is the main book in the field, although by now it's already 5 years old. A recent book, The Infinite Machine, is a readable account on the development of Ethereum. Cryptocurrencies and blockchains are very fast-moving areas, and there is a lot of innovation in this space. The long-term success of cryptocurrencies, such as Bitcoin and Ethereum, is far from certain. But nonetheless, the beautiful ideas being developed will certainly find applications in the years to come.